Hello and welcome to Joseph's night class. We are going to be moving on to Algebra 1, number 2. That's the title of your worksheet. On the left side where it lists the strand. And let's go ahead and get started. So what we're going to be doing today is very similar to the equations we saw in some of the earlier worksheets. We're going to solve for x using absolute values. This is a combination of a few of the different videos and skills we've worked on so far. So in a way, there's not a whole lot of new things, just different ways of doing them because we're having to combine previous skills that you've learned. So let's go ahead and get started. First, a reminder that absolute value is treated like parentheses. So when it comes to PEMDAS, order of operations, you have to go parentheses first. That means absolute value comes before anything else. So the first thing you do when you see a problem like this is you can't just go plus 5, x equals. You can't do that. When you see absolute value around an x, you're going to have more than one answer, which was true when we didn't have this plus 5 equals. Just solve for x without the another digit there. We usually had more than one answer. That's also going to be true here. So to set this up, you are going to need to make two equations out of this to find both answers. Because you're not just going to be able to take x equals like 4 and make it negative 4. So here's how you do it. First, write an equation where you just ignore the bars. X minus 5 equals 3. Now make another one where the x minus 5, or everything that's in the bars, put in parentheses, put a negative right there, or a negative 1 if that helps you remember what you're supposed to do with that. And then don't change the equals. Don't change anything that wasn't inside the absolute value bars. So the next thing you're going to do is solve both of them. And when you get to the end, you're going to have an answer for over here and an answer for over here, and that's your answer. So let's go ahead and solve it. We'll start with the easy one. Plus 5 plus 5. X will equal 5, 6, 7, 8. And, we're done. X equals 8. Now we're going to go over here. Now we need to distribute. So that leaves us with negative 1 times x is negative x. Negative 1 times negative 5 is positive 5. You're already starting to see how we're going to get a different answer. Equals 3. Now solve like normal. Minus 5. Negative x is going to equal 3 minus 5. The numbers are different. 5 is bigger, so we're going to have a negative answer. Subtract them is 2. Negative 2. We can't leave that negative there, so we're going to divide by negative 1. Divide by negative 1. And x is going to equal positive 2, because a negative and negative is a positive. So the answers are 8 and 2, and that's it. That's how you solve these. We're going to do a few more examples. Each of them have some slight variations, but this is how we're effectively going to solve all the rest of these types of problems. Let's go to the next one. Number 2, solve for x. 2 times the absolute value of x equals 12. Okay, a little bit of a curveball, but we're pretty much going to do the same thing. We're going to make two equations. So again, just like the first one, for the first problem, we're going to at first ignore the bars. 2 times x equals 12. Now some of you are asking, why do I make parentheses? Because remember, we're getting rid of the bars, but we still have to treat the bars like parentheses. So that's why I'm going to put the parentheses there, just as a reminder. Now over here, the 2 is not inside the bars, so you're not going to apply a negative to that for your negative side of the equation. So the 2 remains the same. And remember that negative distributes to everything inside, so we're going to go ahead and do that. Everything inside the bars. Negative x equals 12, because you don't do anything at all to anything outside of the absolute value bars. Now, solve. So 2x equals 12, divide by 2, divide by 2, x equal 2 divided by 2 is 1, 12 divided by 2 is 6, so I'm going to put that down here. And then over here, 2 times negative x is negative 2x equals 12. Solve, divide by negative 2, divide by negative 2. X equals positive 12 divided by negative 2 equals negative 6. Put that down here. And then we're done. X is 6 and negative 6. Now I'm using this and to kind of highlight how I'm doing this, where you got two different equations and two different answers. But on the test, and you can write this way too if you don't want to write and. You can just do a comma. So 6 comma negative 6. Either way, it really won't matter for you on the case. I think you'll be able to figure out whether it says comma or and. This is just kind of for note-taking purposes, which I want to see on your guided practice. Question number 3. Solve for x. 3 times the absolute value of x plus 1 equals 13. Alright, so this one's actually not that different from the last one, so let's get into it. First, we do it as if there were no bars at all, but we still treat them like parentheses. And our second equation, 3 negative x plus 1, it's getting a little wobbly on me there, equals 13. Again, don't change anything outside the bars. Solve. 3 times x is 3x plus 1 equals 13 minus 1 minus 1. 3x equals 12. Divide by 3. Divide by 3. X equals 4. So I'm going to put that down there for part of my answer. Over here, distribute, and negative 3x is the result, plus 1 equals 13 minus 1 minus 1, negative 3x equals 12. Divide by negative 3, divide by negative 3. X equals positive 12 divided by negative 3 is negative 4. Now you might have noticed that on number 2 and on number 3 here, we ended up with opposite numbers. That will happen. That will be common. But it won't always happen. The next problem that we go into, you'll see that. But you can't just go, oh, well, this is 4, so this one has to be negative 4. Sometimes yes, sometimes no. Final question. Solve for x, absolute value of 2x minus 3 equals 11. So this will be an example. We'll probably get two different numbers at the end. So, two equations. One where we don't worry about the absolute value. We'll leave it as it is. I just dropped off the parentheses because there's nothing outside of it on this side of the equal sign anyways. This one, I'll go ahead and do the parentheses just to spell it to you, just so to emphasize you're putting a negative there. It doesn't affect the 11. Alright, so we'll solve over here over the easy one first. Plus 3, 2x equals 14. Divide by 2, divide by 2. X equals 7. And over here, first we have to distribute. So negative, remember, hidden 1 times 2x, ninja 1, negative 2x. Negative 1 times negative 3 is positive 3 equals 11. Solve as normal. Minus 3, negative 2x equals 8. Divide by negative 2, divide by negative 2. X equals positive 8 divided by negative 2 equals negative 4. So your x equals 7 and negative 4. This is what I was trying to tell you just a little bit ago. You can't just do opposites. If you had just solved this and gone 7, ooh, negative 7, and put that as your answer, on the Casey, that would be an answer choice. That will be a trap they will set for you on this kind of a problem, because this will show up on the KC just like that. Solve for x, an equation inside, or formula inside the absolute value bars equals a number. That's going to happen. They will be setting an opposite trap for you. So don't just do opposites. Go through the motions. Make two equations, solve them all the way down, and confirm. Now you might find out in the end that it is opposites. You're not wasting time because you're just making really, really sure that you're not falling into a trap. Okay, go ahead and go on to the practice questions. Don't go on to homework without checking with me first. Thank you.